Hello there, Algebra students. This is Mr. Kashi speaking. Obviously, I can't be there today, but we'll go through notes through the video here. As you can see on the left-hand side on the whiteboard, not on the recording here, you can see the schedule for today. Hopefully, we've collected the 9-6 assignment already, and you've taken the 9-5, 9-6 quiz. And now we're on to 9-7 notes, which I'll be showing you on this video. And then hopefully, after we go through the notes, I'll have time to go through a problem or two through your worksheet on this video as well. So we'll go ahead and start our notes. Obviously, we're factoring a trinomial again today. Okay, 9-7 factoring special cases. Okay, that's on page 528. Please take your own notes on your own paper. Obviously, split it up. Please pause this video whenever you need time, but I kind of have to go through things here to make sure it all fits in the time allotted for us. So our first key point is just simply perfect squares. And using our special cases today, it's going to be a lot easier if you're able to identify perfect squares. So we're just going to list them out here. 1 times 1 is 1, 2 times 2 is 4, and so on and so forth. But we do want to record them so we realize when we need to use these different rules that we're going to learn today. 4 times 4, 16. 5 times 5, 25. And then we'll just go up to 100 real quick. 6 times 6 is 36. 7 times 7, 49. 8 times 8, we get 64. 9 squared is 81. And obviously 10 squared is 100. Okay, there are a lot more. Obviously, you can keep going. 11 times 11, 12 times 12, and so on and so forth. These are the most common ones that you're going to see today. And these are the ones that are going to help you out the most. Our next key point will be the rule that we need to use. And these are the exact opposite of the rules of what we saw in 9-4, which was multiplying special cases. Now we're factoring special cases. These are called perfect square trinomials. Okay, so obviously a new key point. Perfect square trinomials is that key point. And then we have two different types of expressions here, two different types of rules. And the first one is a squared plus 2ab plus b squared. And that is going to be set equal to a plus b times a plus b. And a lot of you know that already too. We can write that as a shorthand as a plus b squared. And then down here on the second one is a squared minus 2ab plus b squared. That's going to be set equal to a plus b. Oh, sorry. A minus b times a minus b. And that's going to be, obviously, in shorthand, be a minus b squared. Okay, so we're going to be using those in a few examples here. It's important to know the shorthand. Obviously, now what we're going to be doing today is we're going to be starting here, and we're going to be ending up here. Where in 9-4 we actually went the other direction. We started at a minus b squared, and then ended up at a squared minus 2ab plus b squared. So go ahead and pause the video if you still need more time to record that. But we'll move on to this first couple of examples. So we have x squared plus 10x plus 25. And really the only thing that you need to know is about c. Okay, so you need to take the square root of c. So in this case it would be the square root of 25. And that would be 5, obviously, from our notes before. Okay, so how we would set that up in a factored form would be we'd do our parentheses. Okay, obviously x squared, we're going to split that up into x and x. And if you take a look at your half sheet, they're both positive, so these two factors are going to be positives as well. And then we're going to have a 5 and a 5 here. Okay, so obviously x times x is x squared. 5 times 5 gives us the 25. And then if you wanted to check, you do the x times 5 and the x times 5, so that'd be 5x plus 5x, and that gives us our 10x, which is our b up at the top there. So that's how we know it works. Okay. So really, we have x plus 5 times x plus 5. If you wanted to go a step further, which is always nice to write a little bit shorter, you don't have to do that as write the same thing twice. You just put x plus 5 squared. All right. Then we have t squared minus 14t plus 49. That is that's the next example that we're going to go over. Okay, so obviously square root of 49 or our c. Oh, square root of 49 is 7. And we'd split that up then. We'd have t over here. We have t over here. We'd have 7 and we have 7. And now the last step today is going to be figuring out, okay, which one's positive, which one's negative. Well, if you look at your half sheet that gives you those guidelines, if b is negative and c is positive, like in this case, it says that they're both negative. And we'll find out if that works right here, because if we have t times negative 7, that would be negative 7t minus another 7t, and that gives us the negative 14t that we need. Okay, so once more, we need to simplify that down to t minus 7 squared. So what I want you to do is go ahead and try these two practice problems on your own. And if you could pause the video right now, because I'll be revealing the answers here. Then you can take some time, go as long as you need to for these practice problems, and then go ahead and check the video once you're done. So I'm just going to put the answers up here. So if we're splitting this up in these perfect squares, okay, n and n, we're going to have plus and plus. We're going to have 8 and 8. So shorthand would be n plus 8 squared. And then over here, square root of 16 would be 4. So we'd have x plus 4 times x plus 4. And that would be x plus 4 squared. Okay, so now we're going to move on to our next piece. This one's a little bit shorter. It's the difference of two squares. Okay, so whenever we have a squared minus b squared, we always get a plus b times a minus b. Okay, so whenever you have a squared minus b squared, it's going to be factored out into the form a plus b times a minus b. Okay, go ahead and pause it if you need more time to record, but I'm going to move on to these next examples here. Okay, so here we still have to take the square root of that second one. So really, a squared would be, well, in this case, a would be x, and then we have b squared, which is 64. So the square root of 64 is 8. So here we would have x plus 8 times x minus 8. And that's really all we have to do, is we have to take the square root of 64, make sure one's positive and one's negative. They will cancel each other out. That's why we don't have a b factor in this. Okay, this one's a little bit more tricky. We do actually have a perfect square out in front of the q, so we want to take the square root of 25 as well as the square root of 9. Okay, and so here we'd split it up as 5q and 5q, and then we're going to have a plus 3 and a minus 3, because the square root of 25 is 5 and the square root of 9 is 3. And so we're going to put the 3's in the second spot in each one of those. And there's no such thing as we can't do 5q plus 3 squared, because this other one is 5q minus 3. They're not the same thing, so we can't square them. So that would be the factored form of 25q squared minus 9. And finally, we'll do two more practice problems on your own. If you could go ahead and pause the video right now, give yourself some time to practice these, and you can wait for the answers here in a sec. All right, the factored form of p squared minus 49 would be p plus 7 and p minus 7. The 7 times the negative 7 gives us the negative 49. And here we'd have to split up the square root of 4 would be 2, and the square root of 81 would be 9. And so here we would go 2m and 2m, and here we would go plus 9 and we go minus 9 right there. That's how you would split those up. Okay, so that's it for the notes. Unfortunately, we don't have enough time to go over any worksheet problems just due to our limited time on the video, but I will be going over any problems that you have next class period. Okay, there is a worksheet that for you. It is a CUDA software worksheet that is 22 problems long. Obviously, the ones later on are something that I could go over next time in class. Okay, have a good rest of the day, and we'll see you next time.